Okay, today I want to go over solving equations with one step. Okay, so those are equations that require only one step to solve for x. All right, so there's two things to keep in mind, and that is to always use the inverse operation. If you notice an addition sign in the problem, then you're going to subtract to solve it. If you see a multiplication sign in the problem, then you're going to divide to solve it, and so on. We're going to do 5 examples, okay? One for addition, one for subtraction, multiplication, division, and then one for reciprocals. And if you remember, a reciprocal is something like this. If you have a fraction like 5 over 8, its reciprocal is just it flipped. So the reciprocal of 5 over 8 is 8 over 5. And to tell if they are reciprocals or not, all you have to do is multiply them, and they'll add up to, or they'll multiply out to be 1. So 5 times 8 is 40. 8 times 5 is 40. So that's equivalent to 1. Reciprocals will always multiply out to be 1. Let's get to the first example here. Addition. I think these will go pretty quickly. Okay, so our goal is to isolate the variable x, and we're just doing one step to solve this. I see a subtraction symbol here, so I'm going to add 5 to both sides. So I'm going to add 5 to both sides. On the left, I get negative 6 plus 5. Well, that's just a negative 1. On the right, I get x. So I have isolated my variable. My variable is all alone on the right-hand side. And x, I know, is equivalent to negative 1. Okay? And if we plug that in, that's correct. Negative 6 is equal to negative 1 minus 5, right? So that's correct. Let's go to example 2, subtraction. Here I need to isolate the x. I see that I have an x plus 15 here. So I'm going to use the inverse operation, okay? The operation that undoes an addition is subtraction. So I'm going to subtract 15 from both sides, and I'll get x is equal to 5. Okay? So that's my answer. If we do a little check, 5 plus 15 is equal to 20. Well, that's correct. All right? Next problem, division. Okay? So I see that 12 is being x is being multiplied by 12 here, right? If they're just pushed together, 12 and then a variable, that means they're being multiplied. So 12 times x, the inverse operation would be division. So I'm going to divide both sides by 12. Remember, one thing I forgot to mention is that what you do to one side of an equation, this is an equation because it has an equal sign there, what you do to one side, you have to do to the other to keep them equal. So 12 divided by 12 is 1, and 48 divided by 12 is 4. Okay, so there we go. X is equal to 4. Does that make sense? Well, we could do a little check. 12 times 4 is equal to 48. 12 times 4, that is 48. So this does work out. Next example, multiplication. Okay, so I see that my x is being divided by 6. So what do I have to do? I have to multiply both sides by 6. Those cancel out, right? Because it's 6 over 6, which is 1. So x is equal to 30. Okay, does that make sense? Let's see. If I plug in 30, I get 30 over x is equal to 5. Well, 30 divided by 6, that's 5. 5 is equal to 5. We're good. And on to the next example. Example 5. Okay. So here, we're going to use the reciprocal. If you remember, reciprocals multiply out to be 1. And you can think about them as just the fraction flipped. So if you see a fraction like this, you can think about its reciprocal as 7 over 3. So let's just make sure. 3 times 7 is 21. 7 times 3 is 21. That's equivalent to 1. Good. Those are reciprocals. So we're going to end up using this 7 over 3 for our problem. Let's take a look at the problem. Here you have what you could say is, okay, we have an x divided by a 7, so maybe you'd want to multiply by 7, and then we have it multiplied, the x multiplied by 3 as well, so you might think you want to divide by 3. Well, that's essentially what we're doing if we multiply both sides by its reciprocal. Okay, so this is really sort of a two-step problem, but you can sort of do it as a one-step if you think about it in this way. Okay, so we're multiplying the left side by the reciprocal. Well, these two numbers, 7 over 3 and 3 over 7, if I multiply those together, they're going to equal 1. So that's just going to be an x on the left. Here on the right, I have 15. Well, I can divide it by 3. I can reduce this, right? 3 goes into 3 once. 3 goes into 15 5 times. And then I could just multiply across. 5 times 7, that's 35. So my answer here is 35. Okay? So those are all the examples I have for today. Please let me know if you'd like to see any more examples. Thank you.